Right, round two on the video. First one did not stick. So we're going to talk about circumference and arc length. So circumference is essentially your perimeter around the circle, so the distance around the circle, and we will call that C, okay, for circumference. The next piece that we will want to know is the diameter. So hopefully you guys are aware of these terms, but it felt like it might bear repeating. The diameter is the distance through the circle from one side of the circle to the other, but the key is that it has to pass through the center point. So it's the maximum length from one side of the circle to the other. If it doesn't pass through the center point, that's something that we call a chord, and something that we're probably not going to discuss a whole lot. But the diameter passes through the center point and connects two sides of the circles, and surprisingly or not, we will call that D. The last piece that you should know is the radius. The radius is half the diameter. Radius, which is R, or half the diameter, is the distance from the center of the circle to any point on the outside of the circle. All right, so we're going to use radius and diameter to find the circumference. The only other thing you'll need to know is pi, which we have, I don't know if we've used it much in geometry so far this year, but hopefully you guys have seen and experienced pi before. Pi is the ratio between the circumference and the diameter. And so it's a constant. It doesn't change. It's always the same value. So frequently you may just be asked to leave it as pi without multiplying it out. And this is because pi doesn't end. It's got infinitely many decimal places. So if we were to chop it off at 2 decimal places, then we're losing out on a good portion of the number there. And so that's not something that we necessarily call exact. I also may have you multiply it out and round to 2 decimal places. And realistically, this is what you should expect. This is exact enough because realistically, you don't need 100 decimal places if you're trying to find circumference in your day-to-day life. But exact is something that mathematicians like to use, and given that your homework is online, that is frequently a way that it is graded. And so if it asks for exact, then you're not going to multiply it out. If it asks for multiple decimal places, then you should multiply it out. And we'll discuss that more as we go through a couple of the examples. So the two formulas for the circumference are, the first one is that the circumference is pi times the diameter. Pi times the diameter. And we already discussed that the radius is half the diameter, or the diameter is equal to 2 times the radius. So another formula we may use is 2 times pi times the radius. And in my experience, the second formula is far more frequently used. I don't know if it's just because people prefer using radius, but this formula is way more frequently used. And so you can expect to use that formula potentially more than pi times the diameter. So that being said, let's look at our first example problem. So the first example problem I have here is we want to find the circumference, and right now we have the diameter, which is 15 feet. That's D, and we want to find the circumference. And so you'll recall that the circumference is the perimeter around the circle, and the circumference is equal to pi times D. Well, we have D, and we know that pi is a constant, so it's not going to change. So we can go about finding the circumference. So all we have to do is plug in our values, /value, and pi times the diameter, which is 15 feet. And so if you were asked to give an exact answer, then you would give 15 pi. and this would be where you stopped. So that would be exact. If you were asked to round to a couple decimal places, well then at that point, that's when you want to plug it in. So let's do that. So I'm going to go to Desmos, and at Desmos I want to plug in 15 times pi, and I get 47.12. 47.12, and you'll recall that that is in feet. So the distance around the circle is 47.12 feet. Okay, so pretty straightforward. All you're really doing is plugging in and solving. As long as you can identify the parts, it should not be, hopefully, too bad. So for example 2, we have been given the circumference. So the circumference in this case is 100 feet. That is the distance around the circle. Okay, and presumably, just based on the picture, we're going to be asked to find the radius, and you'll recall that the radius is the distance between the center of the circle and any point on the outside of the circle. So I want a formula that has circumference and that has radius, and if I recall correctly, then circumference is equal to pi d, but is also equal to 2 pi r. And so we will go about using that formula. So I want to plug in for anything that I have circumference, 2 is a constant, pi is a constant, and so once I plug in for circumference, I should be able to go about finding what my radius is. So the circumference is 100 feet, and I want to get r by itself. Okay, so in this case, I have to solve for r. Shouldn't be too bad. And so I'm going to leave r on the right side. It's already in the numerator, and I think that's going to be the easiest way to go. So I'm going to divide by 2 on the left, and if I do that on the right, then I have to do it on the left as well. And I'm going to divide by pi on the right, and if I divide by pi on the right, I have to divide by pi on the left as well. And so now I'm left with r is equal to 100 divided by 2 pi. Okay, and this is our exact answer. So if you were asked to give an exact answer, that is that. If you were asked to round to a couple decimal places, then this is where you go to Desmos and plug it in. So we'll do that as well. So I want to plug in 100 divided by 2 pi. So 100 divided by 2 times pi is 15.92, which is our radius. And you'll recall that our units were in feet, so 15.92 feet, which also means that the diameter would be about, what would that be, 31.84, so twice the radius. You could also find the diameter if you wanted to, right? So that's really all that encompasses circumference. The second portion is arc length, and what arc length is we want a specific portion of the circumference. So if the entire circumference is, 45 units, then maybe we just want 15 of that, or we want 1/5 of the circumference, something like that, and that is what arc length is. So really all you need is the formula for the circumference, and then we need to figure out how much of the circle we want, and so we will use angle measures to do that. So for this circle here, I've got the arc length in light blue there. So the arc length is a portion of the, where's my words? A portion of the circumference, okay? The only extra piece of information we need, in addition to the radius, which we already needed for finding circumference, is the measure of this arc right here. Right, so you notice that we've got 2 radii right here, and they're forming an angle. Well, if I want to find the measure of that arc length, then I need to find the measure of that angle, that angle measure there, and then I know that a circle is 360 degrees. So if I know, that I have 90 degrees out of 360 degrees, then that's 1/4, or I want a quarter of the circumference, right? And so then I'm taking a portion of the arc length, or a portion of the circumference, and that's the arc length. So it just adds one extra variable, one extra step, right? So the formula is arc length is equal to the circumference formula. So I'm going to use 2 pi r. You could use pi d, but 2 pi r is going to be more frequently used. So you should expect to use that more. And then I want to use my angle measure that I got. So this gives me the circumference. Now I need to scale that by how much of the circle I have. Well, if I take the angle measure and divide it by the total angle measure of 360 degrees in a circle, then that will give me how many or how much of the circle that I want, right? So let's see how that works in example 3. Okay, so presumably I want the arc length formula, and I want to plug in for some values. So arc length, and so first off, you'll notice that the radius is 3 centimeters, right? And so both of those radii are 3 centimeters. All radii are the same. So radii 3 centimeters, and we're looking for 72 degrees worth of the circle. So that angle there in the middle tells us that I want 72 degrees of the circle, and you can kind of see that arc length notated by that light blue there, right? So let's start plugging things in. 2 times pi times r, the radius is 3, so times 3. That would give us the circumference, which the circumference of the entire circle is 6 pi, which is a little over 18. So I should expect that any answer I get out to be, significantly less than that, right? 72, as it turns out, is 1/5 of 360 degrees. So we should expect whatever we get to be about 1/5 of 18 point something, right? So next I'll take my sector size, which is 72 degrees out of 360. And so you can simplify. Now let's say that you look at this and you're saying, well, I don't think I can really simplify anymore. That's fine. This is where you would go potentially get a calculator and plug it in. The only value to being able to simplify is if you were asked for an exact answer, then I would expect you to have simplified. So I'm going to do that. 2 times 3 is 6 times pi, and I happen to know that 72 degrees divided by 360 is 1/5, so 72 is 1/5 of 365 degrees, so I can simplify that down, and then 6 times 1/5 would be 6/5, so 6/5 times pi, and this would be your exact answer if you were asked to give it. Alternatively, if you were asked to give a decimal answer, which I would anticipate for arc length, but that may not always be the case, you would want to plug that in. So you would want to do 6/5 times pi, which is 3.77, which is about 1/5 of, or exactly 1/5 of 18 point whatever, 6 times pi, right? And this was also in centimeters. So our arc length is 3.77 centimeters. That's the distance around the within that 72 degree segment there. So it's a portion of the circle. It's not the entire circumference. It's just what we call an arc length. If you have any additional questions or would like any more examples, feel free to reach out via email. Otherwise, this should be plenty to get you guys started and going on your assignment, first assignment for this week. So let me know if you have any questions, and I hope you guys are all doing well.